Alright, this is a short video explaining this in-class activity called the 8.3 Special Triangles Exploration. If at any point you need some extra time to copy things down, just have the teacher pause the video and make sure you're listening. There will be times when the video needs to be paused and let you guys try and do some of the work on your own. And make sure if you have any questions, you raise your hand and ask. You can always go back and replay any of this. But we're going to go ahead and start. So I'm going to give you guys instructions on how to set this up first. We're going to explore kind of, again, where these special right triangles are. In the video, we talked about what they are, the 30, 60, 90 triangle and the 45, 45, 90 triangle. But this is going to help you understand what their side relationships really are. So we're going to do this. First, I want you to take your square in this front side. Make sure you're on the side with the square. We're going to draw the diagonal. Just one, and that creates these two triangles. And we're going to focus just on one of those triangles right now, because by cutting that square in half, we get one of these triangles. Okay. Now we know that this angle is a 90-degree angle because it was the angle of the square. Okay, so we know that last angle is 90 degrees. But then each of these two angles was part of a 90-degree angle that was cut in half. So each of these is 45. Which is why we call this a 45, 45, 90 special right triangle. Now, I also want you to notice that this side of the triangle, which is a leg, is congruent to this side of the triangle, which is the other leg. Remember, legs make up the right angle in a right triangle. This diagonal that we've drawn in is called the hypotenuse. All right? And so what we're doing in each of these, I've given you some squares, and I would like for you to, again, draw a diagonal on each one, label it C for the hypotenuse, and then you're going to use the two sides of the square that make up the legs of that triangle in your Pythagorean theorem. And you're going to solve the Pythagorean theorem for that hypotenuse in each one of these, but I want you to do simplest radical form. Okay, and so I'm going to do number one with you, and then I want you guys to do the next three. So the legs are both 3 and 3. And so to start to solve this equation, we square 3 and 3. 9 plus 9 is 18. Then we take the square root of both sides. To get that C is the square root of 18, but that is not simplest radical form. Remember that we need to make sure this number has no perfect square factors other than 1. Well, 18 can be divided by 9, which is a perfect square. And 18 divided by 9 is 2. So square root of 18 becomes square root of 9, square root of 2. And the square root of 9 is 3. So the hypotenuse, or the diagonal of that square, is 3 times the square root of 2. Or we could read that 3 radical 2. Okay? So I want you guys to try 2, 3, and 4. And at this point, you'll need to pause the video. Okay? If you are still working on these, again, pause the video to give yourself enough time to finish 2, 3, and 4. Okay? Or give the class time to finish 2, 3, and 4. But these are the answers you should get on each of those. Okay, on this one, when we work it all out, we get that C is 5 square root of 2. And the work on these should support that you also get 4 root 2 and 7 root 2. And what I want you to notice is this number in front of the root 2 on all 4 answers. And notice where it comes from. And so you should be able to notice a pattern. And I want you to try and take a guess at what that pattern is. What do we do if we are given the side length of a square to find the diagonal? You should notice we just take that side length times the square root of 2. And that is true for any special right triangle that is a 45, 45, 90 triangle. It's always the leg times square root of 2. All right, let's turn the page. Okay, we're going to kind of do the same thing, but we're going to look at where we get our other special right triangles. Okay, if I were to draw a perpendicular bisector of this this triangle, here's what that looks like. It's just a line that cuts the triangle in half vertically. I could have picked any vertex to draw from, but it's easier to see this way. Okay? And that creates a right triangle. Again, we're just looking at that right triangle, that half, where this is the side, and this is half the side, and this is the height. And so we get some angles here. We have a 90-degree angle again. All right? And then this angle, remember that all three angles of an equilateral triangle are 60 degrees. So this is 60. But when I cut this angle in half, that's now 30 degrees. So we have a 30, 60, 90 special right triangle. And when we look at that, we want to notice the relationship of all these sides. So once again, I'm going to work this one out with you. Okay? When I draw in that perpendicular bisector, or the altitude of the triangle, that's what that can be called, I get a right triangle where the hypotenuse is the side. So I know the hypotenuse this time. And then this leg, we can call the short leg, because it's shorter than that. And it's half the side, so that's a 2. And so this time, I want us to find what that altitude is, and that's another leg of the right triangle. So when we plug into Pythagorean theorem, we're going to plug in for A and C. Because C is always on the other side by itself. All right? And so we're going to solve this. Subtract 4 from both sides. Take the square root of both sides without using a calculator, at least not the square root button of the calculator. And this time, we're going to try and solve this in simplest radical form also. Now you should notice the largest perfect square factor of 12 is 4. So if I divide 12 by 4, the other number is a 3. So the square root of 12 can be better written as 2 square root of 3, because the square root of 4 is just a 2. And so I want you to find these other 3 lengths for that altitude. Again, you'll need to pause the video, give class time to work these out. When everybody thinks they have an answer, you can continue watching the video. And these are the answers you should get. Okay, here this altitude is 5 root 3, and you'll notice 5 is half of the side length, or the length of that short leg. 3 root 3 here, because 3 is half of 6, and 4 root 3, because 4 is half of 8. So here we have some other relationships of where these things come from. Okay, that this short leg, if I start with that measurement, I can multiply it by root 3 to get the long leg. And then also if I take the short leg and multiply it by 2, I get the hypotenuse. Okay, so we're going to talk about this question again when I come back to class. All right, at this point, I do need to make sure the teacher in here pauses the video and then passes out the second worksheet, okay, that looks like this, 8.3 Special Triangle Notes. And then we're going to take some additional notes on this to make sure that you fully understand how to solve some of these problems. Okay, if not everyone has one of these, pause the video again to make sure everybody has one. But we should be ready to look at this. And this is where we're going to start putting the pieces together. All right, so in the diagram here, instead of using an X, they use the letter L to represent the legs of the 2 sides of this right triangle. These are both legs. And then remember, all we have to do is take the length of the leg times radical 2, or root 2, to get our hypotenuse. So again, if I call them X, that hypotenuse is X square root of 2. I'll write it over here again for you. If the legs are both X, the hypotenuse is X times square root of 2. So there's a shortcut to remembering how to do this. Okay, to go from the leg to the hypotenuse, meaning if you start with knowing what the leg is and you're trying to figure out the hypotenuse, all you have to do is multiply by square root of 2. But if you're going backwards, if you're starting with the hypotenuse and going towards what one of the legs is, meaning they give you the hypotenuse and you have to find the leg, you just divide by square root of 2. Okay? So here, if this side in this example is 13, that's a leg. The other leg is also 13, but the hypotenuse is 13 times the square root of 2, because we multiply by root 2. And that's how you leave your answer. That is simplest radical form. But in the example in the middle, since I start with the hypotenuse, and to go towards what the legs are, I need to divide by the square root of 2. But remember, you can't leave your answer that way. In the previous lessons, we looked at how to fix this by multiplying the top and bottom by the square root of 2. Okay, which gives us 10 square root of 2 over 2. Root 2 times root 2 is 2. And then the 10 over 2 can simplify. And so that's to 5 root 2. So that's what the legs are. Both legs end up being the same. It's 5 square root of 2. Okay? And I'm not going to go through a ton of more examples, but you get the idea. All right, and let's go to the back side of this page. On our 30, 60, 90 triangles, remember we started by drawing this segment to get our 30-degree angle here, 60-degree angle, and then this other leg. The short leg is always across from the 30-degree angle. So we're going to start by identifying the short leg. If I call the short leg x, the hypotenuse is always twice as long, so it's 2x. And the long leg is always x times the square root of 3. Okay, so again, you can write it in over here. Here's the short leg this time, so call it x. The hypotenuse is here, so this is your 2x. And this is the long leg, so call that x root 3. Okay? So, again, there's some shortcuts to remember. If we are starting with the short leg and finding the hypotenuse, multiply by 2. Multiply by 2. But to go backwards from the hypotenuse back to the short leg, divide by 2. To go from the short leg to the long leg, remember we start with our short leg every time here, we multiply by the square root of 3. And then to go backwards from the long leg back to the short leg, divide. What's the wrong thing there? Divide by the square root of 3. Okay, so in this example, we are given the short leg. This is your hypotenuse. So we take 4 times 2, which is 8. But your long leg is 4 times the square root of 3. In this one, we start with the long leg. I can tell it's the long leg because it's the longer of these two sides. Across from that 60-degree angle. So I take that and I divide by the square root of 3 because I'm going from long leg to short leg. And remember, we have to multiply top and bottom by root 3 so that I get this. And then don't forget to reduce. 15 divided by 3 is 5. So 5 root 3 is the short leg. And now we can take that and multiply by 2, which would make 10 root 3. We only multiply the 5 by 2, not both of them. We're not distributing. Okay? If you have any more questions, feel free to bring them next time, but this should get you started on your assignment today.